So for question 2, we are going to construct a binary search tree in the following order. So we are given a series of words, right? They're all names of cars, but we want to construct it in the following order. So the order of insertion of the binary search tree is going to determine what is going to be the shape of the tree itself. So let's take a look at 2a. So 2a, we are going to first construct this binary search tree, and then we're going to look at how many different nodes need to be searched for us to get to the point. Alright? So in this case, what happens is that we need to look at Lexus, Mercedes, BMW, Audi, Lamborghini, Chevrolet, and so on. Okay, just give me a minute. So I'm gonna freeze the question first. Alright, so the first one that comes in is Lexus. So in that sense, Lexus is going to be the first node that enters the binary search tree. So which means that if you look at the root is going to be Lexus. So then you should see Lexus as the beginning of the binary search tree. It's going to appear at the root. So the next one that comes is going to be Mercedes. And Mercedes is going to start to enter the tree going from the root. So then it's going to compare to Lexus. So then, because M is larger than L, right? So then we're going to go to the right. And the next one is BMW. So we always start from the root again. So BMW is smaller than Lexus. So then we go to the left. So once they enter, they basically stay there, right? So you don't move them around. So even if there is something else that is smaller. So the next one is Audi. So Audi is smaller than Lexus, smaller than BMW. So then you go to the left. And the next one is Lamborghini. Lamborghini is LA. LA is before LE, but L is after B. So then Lamborghini is going to be here. And the next one is Chevrolet. Chevrolet C, smaller than L, larger than B, smaller than L. So then Chevrolet is going to be here. And then we have Porsche, which is after L, after M. And then Maserati, after L, but MA, Maserati, MA, right, is before ME. So then this is, Maserati is here. And the last one is Lotus. Lotus is LO, so it's after Lexus, before Mercedes, so we go to the left and then to the left again. So if you insert a tree in this order, then you should get this following binary search tree. So then if you want to search for any particular node, it essentially, for example, right, let's say if you are searching for Audi, so we're going to start from the root, so we're going to compare to the root first. And then we're going to compare to BMW, because Audi is smaller than BMW. And the third one that we're going to check is Audi, because by the time we come here, right? So essentially, the number of checks you need to do to search a binary search tree for a particular element is going to be the height of, or the level where you can find that element. So for example, Audi is at level 3. So in that case, you're going to need 3 checks, because you're just going down the different levels of the binary search tree. So in the same way, so Lamborghini is going to require 3 checks. Maserati is going to require 3. Porsche is also 3. Whereas this Chevrolet and Lotus is going to have 4 checks each, because they are at level 4 of the 3. Alright? So you just need to be clear how to insert nodes into the binary search tree, and the order of insertion is going to create different trees. Now that we can see that in 2b. In 2b, we are asked to do this in terms of the alphabetical order. Now if we have this construction in terms of the alphabetical order, then we are going to have a different looking tree. in which case, you know, the smallest one is going to be Audi, but it's also going to be the root. Then the next one will be be larger than Audi, which is BMW. So if we insert it in the following order, we're going to get essentially a linear tree, because the next one is going to be Chevrolet, and then you're going to have the Lamborghini, Lexus, Lotus, then you have the Maserati, Mercedes, and finally Porsche. And the number of checks that you're going to need is going to be depending on the level of every node. So to search for Audi is going to be the root, so just 1, 2, 3, 4, 5, 6, 7, 8, 9. Alright, so to search for Audi is going to be 1, search for Lamborghini is 4, Maserati is 7, and Porsche is 9. Okay, and the reason why we get a tree that looks like this is because we are essentially going down in terms of the linear case. Alright, so as long as you're clear about how to construct binary search tree, then you should be able to do this question.